All right, so recording has started. Today, what is that? We'll have to do it. Let me just go through the syllabus part. This is the syllabus first for the first year. Right? A small review: Linux utilities, file handling. File
Sir,
handling.
screen sharing is not started.
Is it? I say so. We have done it. In between, some problem has come. Okay. Okay. So now it is done. Coming back to the syllabus part. And this is a review. First unit only. We are still continuing because we are going into the details and going through a little bit slowly, whatever. Linux utilities. That means so many commands are there. File handling. File handling means how do you open a file, how do you create files, and then how do you search for the data within the files, all such kind of things. So we have already done that. Cat, TAC is the reverse of it, and then like a grep is there, less you have. So all those word count. So like that, there are so many, right? So security by file permissions. So we have seen that by using chmod, change the permissions of a file by using chmod. You have the user permissions, you have the group permissions, and you have permissions for other users, right? So read, write, executable permissions, all those things, right? So we have seen that particular thing. There is a command called chmod, change the permissions of that. Similarly, you have change group actually. You can change the group of a particular file, chgrp, right? Similarly, chown is there, change the ownership of a file, right? Chown. Just try to actually make some effort from your side also, search for these things and try to learn, right? So that is security by file permissions. Process utilities, right? Process means a program in execution. There may be so many programs that are currently running. You want to see what are all the programs that are currently running, right? And what kind of resources that they are using. So for that also you have the commands. One of the very basic command is ps. Just like you have ls to list the files, you have a command called ps to list the processes that are currently running, right? So it has got a number of options also by which you can see the processes owned by yourself or process owned by others also sometimes if you have the permissions and all that. So that kind of thing. Similarly, if you want to terminate a process, right? There are two kinds of processes actually. One is the background process, the other one is the foreground process. You can run any number of programs in the background and you can run only one program in the foreground. Foreground process means the one that has got the control on the input and output devices. Foreground process can actually read the data from the keyboard and display it onto the screen. Whereas the background process normally they should get their data from some other like maybe file kind of and then store the results onto another file, that kind of stuff. So how do you run the programs in the background? By using by giving a command and ending with an operator called ampersand. So if you end any command with ampersand, you are telling the shell to run that command in the background as such. So that even before the completion of that command, the shell will display the prompt saying that the shell is ready to take the next command from the user. The previous command is still running. Normally, like general scenario is you issue a command to the shell, it will run it. After the completion of that, it will display a prompt so that you can run another command, a command after another command. Only after completing one command, it will allow you to give another command. That is a general situation. But if you want to run a command in the background so that even before that program is completed, it will display a prompt so that it is allowing you to run another command. So like that, parallelly, you can run several commands in fact, right? And you can use the ps command to display the currently running processes. You also have a command called kill, by which you can terminate the processes by sending the signals. There is something called signals, processes, and all that, which we will go into details in later classes. So that is about process utilities. Similarly, disk utilities. So you want to find out what is the capacity of the hard disk, how much free space is available, how much of the space is already in use, right? Or what is the space occupied by a folder, one folder, because within a folder there may be so many files. What is the total amount of space occupied by one particular folder down below? So all such kind of utilities come under disk utilities. You have a command called df. Df stands for disk free space, right? Disk free. So it has also a number of options by which you can get like different attributes or details about your hard disk kind of it. Similarly, disk usage, DU is there. Normally, we use DU to find out the disk usage or the space occupied by a particular folder. One folder, how much space it is using, can be found by using DU. Just simply issue like top 10 commands of disk utilities or top 10 commands of process utilities, top 10 file handling utilities, like that on the Google. You will find very useful links, and one can easily learn all those things. It's not a big thing, right? Because already you are familiar with so many commands. General idea you have it. So what is a command, what options they can have, and how to run them and see this thing and all that. So if you simple search on Google by giving top 10 commands on each one of them, right? So that way also you can enhance your knowledge. Networking utilities. Networking utilities mean, so you are like your system may be on a network, and then you want to find out whether a machine with an IP address or a domain name, is it running or not? Is that particular server down or is it running? Right? You can find out by using a command called ping, PING. So you can find out like whether that particular server is currently running or not. In case it is running, you will get some kind of reply and all that. Similarly, you can also find like you can try to even download certain information from another server by using FTP related utilities, file transfer protocol. So again, like just simply issue top 10 networking utilities. Filters. Filter means there is nothing like one this thing. Filter means any command. We call it as a filter if that command reads the data from the standard input. While running the program, if that program takes the data from the standard input, do the required processing and display the result onto standard output, right? When the program is using standard input and standard output, we call such programs or commands as filters. And they can very well used in the context of pipe and all that, so that the output of one command can be passed as input to another command. So like that, you can have a chain of commands connected through pipe and achieve some certain like bigger objective by running a group of commands to work together, so that the output of one command becomes the input for the following command, and that command in turn processes and generates the output, so that that can become the input for the next command, and so on like that. Now we have been doing that for quite a long time. Those are the filters as such. Text processing utilities, same thing, like all these things like sed is there, awk is there. Actually, we have not so far learned those things. Similarly, you have grep, you have head is there, tail you have. So all those related stuff. Backup utilities. Backup means you want to take a backup of a particular folder, let us say, so later on you want to again restore if something happens to this, or you want to take a backup so that this particular folder contains, you want to take it to some other machine and work on that particular thing. So all those things are possible by using backup utilities. So the commands like tar, TAR is a very powerful command actually. Tape archive, it is a short name for tape archive. Earlier days, tape used to be a popular device for taking backups. That is why the command is named as TAR, like a tape archive, it is called. By using which you can very comfortably, like what it is, create one single file for, let us say, a group of files can be combined into a single file, or a folder and all the files below that can all be like copied into a single file by using the backup utilities, and that file can be copied and take it wherever you want and all that. You also have a number of compression utilities and all that. You have a command called zip is there. You have a command called gzip you have, g unzip you have. G stands for GNU actually. GNU zip, GNU unzip. You have a command called compress and also a command called uncompress. So these commands will also help you to create a single file out of a number of files, and take that single file wherever you want, and again you can like expand that single file back into all those individual files. So all those things are possible by using backup utilities. You have a command called DD, disk dump it is called. It's a very powerful utility actually, using which you can copy the disk information, like not necessarily the concept of the file and all that. Even the disk data can be copied as it is. For example, you want to take a backup of an entire disk. You have some, let us say, 1 terabyte hard disk is there. You have another, like what it is, extra hard disk is there, and you want to safeguard yourself. Copy this entire 1 terabyte hard disk, whatever is there, as it is, onto another hard disk. So such kind of things are possible by using backup utilities. There is a command called DD, which is going to be very handy. Disk dump. So like that, several other things are there. Born again shell. So we have spent a reasonably good amount of time on that. So we have been writing shell programs, introduction, pipes, redirection. You have input redirection, you have output redirection. So here document also is a kind of a redirection only. Running a shell script, so you know it, shell as a language, shell meta characters, file name substitution, shell variables, commands, shell commands, environment, quoting, test command, control structures, arithmetic, shell script. So by and large, we have covered. The thing is, you will have to now start learning by working on a Linux machine and all that. And then some review of C language, because C language background is required to write programs in Unit 2, Unit 3, and the following units actually. So because you will be writing all the C programs for those implementing system calls or system program implementation, things like that. So what knowledge do you require? You should have a reasonably good knowledge on arrays in C language, strings in C language, then pointers there, library functions like scanf, printf, scanf, printf, fscanf, fprintf. So like that, there are a number of other library functions. So you should have some good knowledge on that. Pointers, function pointers. So pointers that can store a function's starting address, so that given the starting address of a function, you can invoke the other function. In fact, you don't have to know the name of the function, but if you know the starting address of the function, which is available in a pointer, then you can do all such kind of things. So structures, a structure is nothing but, so it is the previous version of the class actually. Class is the next version of structures. So structures only hold the data, but normally they don't hold the uh, member functions, that kind of stuff. So you can have a lot of data of different data types can be. They can all be combined and create one unit, and we call such a thing as a structure asset. So that one record can be stored with a number of fields, and you can have one structure there as a kind of a data type. Union is a part within the structure where, in order to save memory and all that, we try to allocate the same memory space for more than one field. Whenever we know that any record may contain either that field or this field, but not both. In such cases, normally we go for unions and libraries in C language and all that. So this is the general thing. I think you can now put some effort to learn other things. But today, let me. Do you have any questions or doubts? Someone is there, or she is having this particular problem. At least you. So Arthur, try to come on time, number one, and you have this peculiar problem which others are not having. So I've been telling you, but there is hardly any right improvement on your part. So I don't want to name you. So try to come on time at least so that I will not be disturbed. I can allow you, though there is no issue, or some problem with your mail ID. Anyhow, so the best thing that you can at least do is try to come on time. So it is not acceptable. Okay. So let me go back. So these are the things. Just now we said there is a command called PS, right? So you can just see here. So this is the thing. A process status, process ID. What is the terminal on which this process is running? And what is the time at which it started or whatever? And then like how much time and all that. And what is the actual command? So one command that is currently running is bash, because that is the one that is actually allowing you to accept other commands and all that. So process ID is 2868 for bash and 4475 for this particular PS. So I said just now, like you can run the commands in the background also. One way of handling the background is there is a command called sleep. For example, sleep for 10 seconds, right? So for example, if you give sleep for 3 seconds and just give it, so it's going to just wait for 3 seconds and then display it. It's a very simple utility. For example, you give sleep followed by 10 and then sleep followed by 10 here. And then like in case you press enter, then it's going to be executing in the foreground. Foreground means you will be made to wait. Whereas if you just simply give ampersand here like this, command followed by ampersand, then so it is giving you the process ID of that sleep 10 is 4504, and then dollar is displayed, meaning that it is displaying that. Now if you see what are the programs that are currently running, these are the things. Like you can see those two are there, but 10 seconds have passed by. That's why it is saying number 1 is done. Sleep 10 is already done. So if you by any chance give a little bit more time for the sleep, so that like you can still see the process and all that. Now you execute PS, for example, you can see sleep is still running. 4517 is the process ID, and the same is the case. So you issue once again this particular thing, it is still running. So the moment 30 seconds is passed by, that particular thing will no longer be there as a part of that particular thing. After some time, it's going to inform that. That is about running the commands in the background and all that. Similarly, you can also run commands in a subshell. You can run commands in a subshell, right? So right now it is done now. Now if you see what are the things, that sleep will no longer be there as a part of it. So similarly, you can run the commands in a subshell by using this thing, right? One thing is you can say, for example, you can give the commands in the same line, right? By just simply giving, for example, echo and then hi. And if you give a semicolon, is the delimiter between one command and another command. So it runs echo hi first, and after that, so for example, once again another echo followed by, let us say, oh, this is a network programming, NP kind of thing. So when you queue like this, so you will see hi is executed, echo hi is executed, and after that echo NP is executed, so that they are displayed in the different lines and all that. So like that, any command you can issue a semicolon, another command, a semicolon, another command, like that. In the same line, you want to type in more than one command, you just separate them by semicolons. That is one thing, in fact. That's one thing. Like you also have other logical operators actually, something called ampersand and then pipe symbol or symbol kind of it. So for example, there is a command called true, right? True means true only. Like you run that and then find out what is the return status or what is the status of that. Already we have seen by executing dollar question mark, you get to know that the exit status of the previous command. Dollar question mark means exit status of the previous command. True exit status is 0 because true means it's always true. So 0 means true actually in shell programming. So whenever a command exits with 0, it is considered as successful. Success is considered as true as such. Similarly, there is another command called false that always terminates with what you call non-zero this thing. So it is 1, indicating that it has failed kind of thing. It is a failure. Anyhow, now you can use this, for example. So in case you say true, and then after that you specify ampersand, 2 ampersand. 2 ampersands is the logical operator, actually. 2 ampersands is the logical operator. 2 ampersands are a single operand also. Let us see, let me just see. True ampersand, and then echo, let us say, echo hi. Now, what is the meaning of it now? True is executed, and yes, it is going to be true or a success. And when you are connecting this through logical AND, the total value of this total expression is going to be true only when the second one also is true. That means the total value is not known by just simply knowing the first value of the this thing command, because the first one is true, no doubt, but the total one is going to be true if echo hi also is true as such. So that's why it is going to execute that echo hi. Echo hi will be executed. As you can see, it is executing. True is executed in the background. That's the reason why you have that particular thing. Whereas you specify 2 ampersands like this, even now it is saying the same. Okay, so how do you connect? So one is done, and there also one is done, no doubt. Let me just simply see here, there is more doubt here. logical negation is not and all that, bitwise and these are different, where it is, this is on some other parts actually. Expression complexity we require, pattern not found, logical or, expression comma, this thing is there, levels of equal precedence, command, arithmetic evaluation. These are all arithmetic kind of thing, bitwise and logical and kind of thing. No, this is not. Logical negation, pattern not found. Okay. Pipelines. These are the keywords, select, do done and all that. Control operator, a token that performs like it is one of the following. New line, meta character, pipe symbol. We can use the what it is, Google in fact, no issue. I'm just trying to find out how do you connect two commands through this particular thing. Let me just go through that. Logical and, that logical and, let us try it. Logical operators and shell. Right. This is different actually, but still okay. When I say file name is different, these things are different. But this is a handy tutorial on the other cell facilities and all that. It appears to be. I'm looking for something else, but the other things are really good in this. Batch logical operators, cell expansions, that part is really good here. Summary has gone into. Whatever I'm looking for has not come, but otherwise, the other, this thing is really good here. Two ampersands only, but this doesn't seem to work for some reason. He is asking. This will match if either or both and all that. If not, and test. But nobody has given the answer here. The question is there. This is what we require actually, 2 ampersands only. Okay, it should work somehow. Let us see here. Let us. Okay. For example, if something is true, right? So we say here. mm, WC followed by or ls or echo ls week1 dot txt double ampersand and then word count week1 word. Cannot access this, no such file or directory, and the other one is this. Okay, just pay attention to this. ls week1.txt, week1.txt is not there naturally, so it is giving an error, no doubt. Then wc is not executed. If it is executed, you will get the output of that, right? So, for example, in case it is there, right? That's what you really mean by. If that particular file is there, you want to find out the what it is, the word count of that. If the file is there, you want to give the word count. Otherwise, it will give an error kind of thing anyhow. So, for example, on the same thing, you issue something like this: ls week dot this thing. The file is there, right? If it is there, then you should display also word count. So now you see. So ls output you are seeing, word count output also you are seeing, because the first command is successful, and for the total ampersand to be successful, logical and, if the second one also is true, overall thing is true. So that's why it is running the second one to understand the total value. Whereas it doesn't run the second command if the first one fails. If the first is failed, then the total value is false only. You don't have to run the second one to determine that, right? So that way, if you want to run the second command only when the first is true, make use of ampersand operator. Whereas the same thing, if it is the OR operator, what happens? If the first is successful, it doesn't execute the second one. If the first is failed, only then it executes the second one. I think you should understand like what it is. Like this is the AND operator, it is called, right? So, for example, sleep is there, right? Sleep will naturally be successful always. So sleep followed by 3, something like this, and word count. So after you can see here, it is running the sleep for this thing and also giving the output. Whereas you give, for example, sleep 3 and then give a pipe symbol. Pipe means it's not pipe actually, it is logical OR. It is a logical OR. The logical OR of this whole thing is true if the first one is true, or the second one is true, or both anyhow. If the first one is false, then only you have to run the second one to know the final value. If the first is successful, you don't have to run the second one. So that's why you don't see the output of word count actually now. Right? You see there, what it means is it's not running the word count command. It's running only sleep, because sleep 3 is successful. So OR operator connects that. So second one is not going to. So this is going to be used in shell programs in a number of ways actually, which you can easily understand. So this is about logical OR and logical AND kind of thing. So why is that we have come here actually? So some of them are there as a part of that. Okay, structures, unions, all that. Okay, so let me just give you a brief idea about another interesting command. Actually, it's a kind of a text processing utility, you can call it, very powerful utility. Let me spend some time on that so that you can appreciate like the power of some of the very old one. All these commands are as old as about 50 years or so, right? Those times database also was not that popular in fact. So at that time they used to use these utilities to perform maybe, for example, payroll applications or some kind of employee management systems, such kind of things. They used to do everything using text processing utilities itself straight away. There is a command called AWK. Awk, it is called. It's named after the initials of three popular persons who actually developed this particular utility called AWK. Right? In short, it is called awk. A is the like initial of one of the popular compiler person whose name is Aho. You must have heard compiler book Aho and Woolman like that. That Aho first letter is A here. The last letter K is in fact from Kernighan, who has contributed a lot in the development of C language, Unix part, and all that. Kernighan K is there. In between that W is another person called Weinberger. So all these three have contributed for the development of this AWK. That's why it's called as AWK. And this is a very handy tool actually. If you want to know the syntax of that and how you can use all that, you can say like this, utility commands. Even though I'm asking AWK, it is giving GAWK. G stands for GNU actually. GNU AWK. But actually it is a part of the like Unix utilities way back. And here it is like extended, the new versions and all that is there. Pattern scanning and processing language. So what it does is, it tries to scan for patterns in the lines that it is going to read the data from various files. It's going to read a line, look for a pattern, and then do something. Look for a pattern and then do something, and so on, like right? Pattern scanning and processing language. So, like this, you can see here the awk programming language by Aho, Kernighan, and Weinberger. Awk provides the additional features found in the current version of Brain Kernighan's AWK and a number of GNU, whatever, all those related stuff. So let us see like how we can use this in a very handy manner. Lot of things are there are possible. In fact, on this itself, you can take a small workshop for about 2 days. You can easily conduct. Let us look into that, how we can handle this on these things like cricket bat. Uh, we have the text files, right? T20 records.txt is there, T20 international, whatever. Let us look into that first. What is the format of the data there and all that before T20 international. T20 IS. IS also is there something, we don't know. Summary, whatever. Right. So this is about a part of it actually. Not, it doesn't contain all that. Uh, First serial number, maybe line number, whatever. Player runs average hundreds, number of hundreds. And within the player, you also have India, New Zealand, and all that, right? So various things are there in that particular manner. Okay. So for example, uh, runs code also is there. Runs code by the individual assets. Average is there, hundreds are there. So in between delimited by tab and all that. I want to find out now the total runs scored by all the players. Runs scored by all the players. So in this particular thing. So how many records are there? We can just take a look into by using the word count. Very handy program. Word count can be there. 93, of which the first line is a what it is, the field names and all that. Actually, 92 records are there altogether. I want to find out the total runs scored by all these 92 players to begin with, right? None of the commands, whatever we have learned so far, are helpful in that particular aspect. You cannot do calculations there and all that. What all you could have done using the earlier commands is you can only display like a selected a text and all that. So, but today, let me just give you an idea about it. So, awk general syntax first. Let me give you so that you can appreciate what is going on there and all that. It is a language, in fact. So, awk is there, no doubt, right? And after that, the program can be given by just simply giving the entire program within a single code. Within a single code, that awk script, awk program can be given in the along the command itself, right? In the command itself, you can actually give and give the entire thing within a single code, because within the single code, whatever you write and give it to the shell doesn't do any modifications within the single code. It just passes it as it is to the actual command, whatever it is. That's the reason why you have to give a single code there. Okay. After that, now you will have to specify the pattern and then the actions. Pattern and actions, like that. To begin with, a simple thing probably is what shall we do? For example, we can display the player name alone. Let us say you are interested in the player name or the first column, whatever. Pattern, there is no pattern, right? So here, normal syntax is pattern, and then the action part will be normally typed inside a curly brace. What you are now typing is the action part. So there is a what I call a command or a function within the awk called print in order to print something of your choice. You are interested in the printing the, for example, the first field. So what awk will do is actually it's going to read a file. You have to supply later the file name anyhow. Awk will by default read the file and then read every line. It's going to read a line from the file and then split that line into a number of fields, because it is considering the line as if it is a record. And record is going to be split into a number of fields so that each field is available in the dollar form. You say $1 is the first field, $2 is the second field, and so on like that. $0 means the entire record, right? Entire record is $0. You are now interested in $1. You are not doing any splitting part and all that. So it is awk is doing for you. What all that you have to do is you should work on the fields. And fields have no name as such. Like you may have some name or their player name, number of hundreds and all that, but awk doesn't give much importance to that. It only gives like first field, second field, and so on like that. So right now, let us say we are only displaying the first field, right? We'll go into that a little later, other things, and then curly brace closes. This is the action part. There can be any number of commands separated by semicolon, right? Just like in C language and all that, right? And then a quote ends, single quote ends, right? After that, you have to give the file name. file name, whatever file name, T20 International and all that. So that kind of stuff, right? So this is how it is. The general syntax is awk within single quote, all that. Here, in fact, if you want to have a pattern and all that, you can specify that. The patterns, there are different ways you can specify. One way is you just simply give a slash, and then whatever pattern that you want to have, you want to search for within that particular distance. So what awk will do now is, it's going to read a line and then see whether that line contains this particular pattern or not. If the line contains the pattern, then do or execute these statements within the action file. If you don't specify any pattern here like this, it is applied on every line. It is applied on every line. If you specify a pattern by any chance, then it applies. That means it executes these commands only on the lines that contain this particular pattern. Right? It examines. Just like you have grep is there, right? Grep followed by a pattern and then the files. So grep, what it is doing? It is displaying all the lines within the file that contain that particular matching pattern. So first general idea you form it. You try to understand. Then it becomes so simple, right? So you can actually give any number of things like this. Any number of things like this, in fact. Like you can have another pattern here, pattern 2. So maybe here you say pattern 1, right? So what to do and all that. And then the actions corresponding to that, right? Actions corresponding to the second. Actions are commands, like either way you normally call it. So like this, actually, there can be any number. And then the general pattern, like which is going to be executed on every line, is going to be in this particular format. Is going to be in this particular format. And after that, whatever. This is how it is. There is some more actually. There is some general pattern which is called as begin, all in capital letters. And then the action part can be there here. Right? So action part can be there as a pattern. Similarly, there is a special pattern called end pattern. End. And then actions for that particular thing. So this is the general idea actually to begin. Begin pattern means what? So whatever actions that are there against the begin pattern, those actions are executed even before reading the data from the file. Here you are likely to specify a file name, right? Here you are likely to specify a file name, the file that contains the data, right? So before reading the actual data from the file, anything that you want to do it can be indicated by using the begin pattern. So you can consider that as if some kind of initialization. If you want to initialize some variables, some such thing, you can do that. So those statements are executed only once before reading the lines from the file. After that, it's going to read a line, do the like a splitting part, and then go through these related stuff. So if the line contains pattern, whatever is there, do this. If the line contains this pattern, do this. So whereas this is going to be done on every line, and then what happens? After some time, when you are reading line, and so on, this file is going to exhaust. When the entire file is completely read, after that, if you want to do something, then that something can be done by using the end pattern. So you want to give a summary of your final results after reading the entire file. Then such kind of things can be put in the end pattern. Right? End pattern is there. We will just write some simple programs, that way you will understand anyhow. But try to appreciate the overall plan, like how programs can be written by using awk, right? So within course, so here what is the advantage? You are not burdened about opening the file, reading the line contents, splitting that and generating the fields. All that part is taken care by AWK. And then on the fields, what you want to do it and all that, you can program it by having this actions part, whatever, and ultimately generate a kind of a small report or whatever, right? That kind of stuff. You can in fact keep this all this code, whatever you are actually saying within the code. You don't have to give in the command itself. You can store all this program in a file and then tell the awk to read the awk lines, awk script from that particular file. Just like you are specifying the data file is going to be this. Similarly, you can tell the program is there in a file by giving one of the options there anyhow. So that is also possible. Or if the commands are very small commands, you can type those commands along with the command itself, right? So now with this as a background, let us now come to this particular thing. So what is our interest now? Let me first display it. This particular thing, right? So first line you don't require. It only contains the what it is, the corresponding this thing, in the sense header asset, field names and all that. So whereas this is also the field actually, the first field, like actually 1, 2, 3, 4, 5. There are 5 fields in each line, of which the first field is the line number actually, line number. Second field is a player name. Third field is a runs code. So if you are interested in displaying the player name, you should display the second field, $2. You are interested in displaying the runs code, $3, like that. So let us now come to this particular thing, and then right after that, slowly you will understand or appreciate how simple it is to write awk programs. So now AWK. So on this itself we will write, so that you don't have to again mention awk. And then a code, awk program. Now awk program, what is our interest? It is a general pattern on every line you want to display. So print the second field. So you say $2. Print $2. Remember, you are putting all these things inside a single quote. $2 now will not be expanded by the shell, because within the single quote you are putting. If you put a double quote there, then $2 gets expanded to the parameter, second parameter kind of thing and all that. So $2, comma, $3 also you want, let us say, that means the number of runs code, $3 you can specify, semicolon. And then curly brace closes, quote closes. See there, a single quote, because it is an awk program, and there are some meta characters. Shell also understands shell has got a special meaning for $. So you don't want the shell to meddle with it. $2 must be passed as it is to awk, as a $2 only. Only then it understands. So that's why you are putting within the single quote, right? So that this is the actual program, and then this whole thing. So when you do this, it's going to generate a number of lines of output, because on every line you are doing something. I pipe it to this. So you can see now player and runs. Virat Kohli runs you are not getting somehow, but for whatever reason, we'll come to that, why it is and all that. So because again it is a delimiter problem. So fields are delimited by a tab in our case, whereas awk by default delimiter is a white space. White space means either a space, tab, or is considered as a delimiter. Whereas tab only must be considered as a delimiter in our case. Space, there can be spaces in the player names and all that. So for that, you have to specify the field delimiter, what is the one. So there is an option there by which you can specify by giving minus followed by capital F. Capital F stands for field name. And then T. T stands for tab actually. T stands for tab. Let me see, I don't know, it's not actually. It's not working that way. T means it's considering T as a T only. Whereas we are interested in the tab actually. How are you going to specify a tab as a delimiter here? The other day we have seen dollar and then single quote, reverse slash T, and then like this. This is how you specify the tab as a delimiter, minus capital F. If it is a comma, you just simply say minus capital F comma. Whereas this tab has got like some special thing in the, it is you can't directly give it there, so you are giving in this particular pattern. Minus F dollar within quote all that. Now when you queue, you can see player and runs, Virat Kohli so many runs and other things and so on. So you are getting all the specific runs and everything, right? So no issue. So first this thing, let it be there, no problem. Now the magic comes. You want to print what you call the uh, the individual things, and at the end you also want to print the total runs scored. Also you want to add it. So such kind of calculations are possible now. How are you going to do that? You can just take a look into that. So uh, uh, just pay attention, like it is such a simple thing. So just simply begin pattern, right? Begin pattern. And then what? Number of runs. So you have some variables, just like you don't have to declare anything, just straight away initialize. So you can say number of runs, NR equal to 0, right? NR equal to 0. That's all. So this pattern is over. Begin pattern is over. Begin, curly brace begins, and then whatever this thing, and close. Whereas this general pattern is curly brace, like there is no pattern there before that, if you see. That means on every line it's going to do it. So it's printing on every line kind of thing. At the end. So not only printing now, we also want to update your NR value. So you can say NR plus equal to NR equal to NR plus what? It is a $3. You have to add $3 to that particular, and then a semicolon. So you are printing the player name, you are printing the number of runs scored. You are also updating the number of runs by adding $3 to that particular thing. But you have initialized in the very beginning by using the begin pattern. Now it's going to do for everything like that. By the time it ends, it reaches the end of the file, then there is a pattern called end pattern. And what is the action to be performed? Print. Print what? Print. You can say total runs. Some colon or whatever. Followed by double quote. Like this, comma. The value of NR. Directly you can specify NR. And then a semicolon. Followed by curly brace closure. Curly brace closure. The pattern must be closed. End, pattern begin, and then the commands, whatever. All that particular mention. See, if you start appreciating the scripting languages, various operators there, the special meaning and all that, then it becomes handy. Right? So otherwise it will be like too many operators there. Right? If you look at that way, it becomes really difficult. So try to appreciate how they are planning the awk there, what is the structure of an awk program, and what it is doing for you. Now you can see, for example, it's going to display player runs, Virat Kohli, so much, and it's going to do all these things. At the end of it, it's going to display total runs scored is 1,28,127. That is the total run score. If you are interested only in displaying that part of it, you can as well say that. You don't have to print in each line. Just simply calculate, right? So this printing part can be removed. You want to print only the total runs score. So in which case, like less and all that also is not required, right? So only one line of output. Total runs 1,28,127. Like this, it becomes very handy. Like to do some kind of calculations and all that on each and every line, whatever that you would like to. For example, within the same thing now, you want to find out the total runs scored by Indian players. within this. How do we know whether it is Indian or not? So we need to understand what is the pattern, what is the structure of this particular thing. So Indian means India is there. This India pattern is there. Look for India in each line. Wherever there is, add the corresponding runs. Add the corresponding runs. That's how one can easily handle that. So probably there may be some other place India is there and all that, right? Whatever. There are different ways, in fact, that one can actually do it, right? So one easiest way, even without knowing awk to that extent, is what? Like by just simply saying grep here, grep followed by, or actually take this particular thing, take this particular thing, and pass on only those lines that contain India. So you can say grep followed by India on this particular thing, T20, IS, and then followed by hyphen, or EC dot. Yes. So you're searching for India in this particular file. Naturally, it is going to display all the lines that contain India. Now pass this as input to the following command. So grep this. So the output of grep will contain all the lines that contain India, and that becomes the input for the awk. That contains the input for the awk. Now you don't have to specify the file name here at the end of it, because the data is coming from the input of the previous command, right? So now you are going to actually have the total runs scored by India actually. So that particular thing you are going to get 14,584. Whereas for Pakistan, probably you want here itself you can specify PAK and then see this 14,770. Maybe those players have scored more within the 92 records or whatever. So like this is one way of doing it. But you don't want to use grep actually. You want to use awk itself. Awk itself is powerful enough to do all this particular business, right? So it can easily do that. So how are you going to do that particular thing? Is here itself. Now you are saying awk followed by all that. NR plus equal to $3. Now here what are we saying? This is a general pattern. On every line, you are adding the $3 is getting added to this. Instead of adding on every line, you just look for India like this. This is how you can give the pattern. The pattern and then the action part. Pattern and then action part. Now it is going to it's going to read a line, and in the line it looks for India. If it is there only on that line only, all this processing happens now. Right? And naturally you will see 14,584. It's now opening you're not using the grep L. So awk has got the built-in grep, the built-in search for that particular thing, and then doing all that particular business. So many more things are possible, in fact, by using this particular thing. So here instead of using India there, you can as well give Pakistan or whatever related stuff. So you'll see 14,770. Either way, you're actually getting that. Just try to go into the details a little bit more by using man followed by AWK, or on the internet, Google for AWK, some of the scripts you are going to appreciate. This is one text processing utility, very powerful utility in fact. Similarly, you have another text processing utility called SED, Stream Editor. SED stands for Stream Editor. Command is SED. This is also a very handy one. All the editing facilities are possible by using this SED. Most of your editing is interactive. The user is doing all that, but not the program. Whereas SED, you can issue the commands. The editing commands can be issued to SED, and specify the file on which these editing commands are to be worked on, so that you can generate the output by issuing these editing commands on the file and generate the final output. So again, SCD has got its own syntax and semantics of that particular thing. Is there. In the awk, if you want, like for example, you want to store your commands and all that in a file, you can do all that particular thing, in fact. Like for example, just now you have specified here this entire thing like this, like this. So here itself one can specify. So program alone can be stored, right? So that then you don't have to give quote and all that, because like it's a program only. So what you can probably do is begin, and then like this. So you're now writing the program. Like this. This is the end pattern. Only the awk script. You just simply store the awk script only. End followed by this, and then pop, and then begin. Whatever. Begin followed by all this. Okay. So now this can be stored. This can be stored. Save as. It should be stored into network programming folder. And this is some kind of what is the script meant for? Adding some of the runs. So just simply say sum dot awk. You can give any extension. Only for our understanding, we are giving the extension name. So just simply say like this. Now come to this particular thing. Clear the screen. Now if you want to run this, see, you don't have to type this entire script here. Remove all this. But now you say that by using capital F, you indicate what is the delimiter for the field delimiter and all that. That part we have done. And then by using another option called -f, minus small f, you indicate the file name corresponding to the script. What is the file name corresponding to the script? Is sum.awk. So minus small f indicates that the following thing is the name of the file that contains the awk program. And after that, anyhow, whatever you are giving is the name of the text file. Here, any number of text files can be given. Then it's going to read data from all those files and then perform whatever is the action part that you would like to tell. So total runs code is like. So this is another way by which when the awk script size is more, then you can write the script in a file and run this in this particular manner. Right? So that is about AWK as a part of it. Similarly, SED we are saying. So you can see here man followed by SED, stream editor. Stream editor for filtering and transforming text. And you have SED followed by script, set script, and then the input file. The stream editor is used to perform basic text transformations on an input stream, in some way similar to whatever all that stuff. So this is again a very powerful one. And all these things are there right from Unix days, about 50 years old, more than that kind of thing. So let us see like how simple it is, some of the operations. Like this particular thing, just now, less followed by this. Every line contains the line number also there. Every line contains the line number in this particular thing. For example, what you can do here is SED. After that set script you have to give actually. That set script can be put within the single code, or if you are not using any meta characters of the shell and all that, directly also can be given. No issue. No issue there as a part of it. So for example, okay, so let us see here what it is going to do it. Set followed by 1, 3. And then do all this. Is it going to be this thing? There is a missing expression and all that. So minus E, you may have to put it. Minus E followed by 1, 3 also is not going to be this thing. So missing command, but this you have to give a P or whatever. So it is printing all of them. Okay. So if you just pay attention to this, minus n, like by default set, what it will do again, just like AWK, set also will read the data for you actually. You don't have to specifically do that. By specifying the file name, set will read the data. It's going to read the first line, do something, read the second line, do something, and so on like that. The reading part is done by set, no issue. After reading everything, do you want to print it or you don't want to print it? That is, we have a choice. When you give minus n, it doesn't print by default. Whereas if you don't give minus n, it's going to print. Every line that it reads is going to be printed. So you are interested in only line numbers from 1 to 3, let us say. That means we have to use minus n. Otherwise, it's going to print all the lines in time. All the lines it will print, and also any other specific things that you do will also be printed. So whenever you don't want to print all the lines like that, we use normally minus n. No print option, we can say. After that, minus E, expression actually, like E stands for expression, set command. Set commands are entered after specifying minus E. And then here, what are you saying? You are specifying the range command. You have different commands inside actually. 0 address command, 1 address command, 2 address command, like that. So here you are specifying 2 addresses. Line number 1, comma, line number 3. That means 1 to 3. All the like line numbers from 1 to 3. What is the action part? P means print. Print all the lines from 1 to 3. Other lines, you are not specifying anything, so they are not going to be there. So that way, if you see now, it becomes so easy to display any line of your choice. For example, you are interested in the lines from 15 to 23, for example. Just simply say that. So you are going to do all that. This part we have done by using tail and head and all that. Right? So that way also we can do it. Whereas set is much more simpler here in that particular context. Right? So it's doing all this. Here you can also perform some kind of operations there and all that if you want. You want to edit something. So wherever NZ is coming, you want to replace with the New Zealand kind of thing and then display it. Something like that, for example. right? So display all such kind of things is also possible. Like here, you are specifying 15 comma 23, and then you are printing here, but you want to substitute, right? You can say substitute here, substitute followed by New Zealand, New Zealand, wherever NZ is there is to be replaced by, let us say, new full name, New Zealand, like this, let us say, and specify in this particular manner. It's doing that, but it's not printing, basically. Now you see, so it is specifying 15, 17, 20, and then doing all that particular thing, but displaying only those lines that are contained in this particular manner. So many more things are possible like this by using SED. Just go through like some what it is, 25 SED examples, something like that in grep in Google search. You should be able to get a number of simple things. Practice on SED as well as awk. Try to get some grip on that particular aspect. C language and all that we will see in the next class. Go through those things like arrays, strings, other things, and so on. Maybe one or two classes we'll spend on that, and then move on to the system calls and all that. I think with this we will stop at this stage. So if you have any doubts or questions, we can address that. Otherwise, we'll stop at this particular stage. So any problems are you facing, or all of you are fine?
Yes, sir.
The only thing is we don't know when we are going to end this and meet in the campus. So that uncertainty is still there. But in spite of that, one good thing is that the software industry is doing fine in spite of all this because of work from home or whatever. So in spite of these difficulties, if you learn properly, and in fact, because it is doing well, it is recruiting more and more number of people, in fact. So that advantage is there. So try to work a little better or harder, whatever, for your own growth. And if you have any questions regarding that, we can address all of them, in fact. So with that, I will close the session today.